All right, so here we go. We got our perfect squares. Okay, we got our perfect squares. And we're going to use those today. Okay, we're going to use those. We are going to be factoring. And one of the shortcuts one of the ways we look at today, you absolutely need to know how to do. Okay, there's no other way of doing it. You have to know it. The second one that we're going to look at, you could get by without knowing it, but you'd have to go through that 7.6 process every time, which, as we know, is a pretty long process sometimes. Okay, so definitely helpful here today. So what we're going to look at first is going to be something like this: x squared minus 25. Now this is different than any of the ones that we've seen in the last few sections because there's only two terms. Right? I've got a binomial now, only two terms. This is what we call a difference of squares. Difference of squares. And when we say squares, we mean perfect squares, really. Because those are both perfect squares. X squared is a perfect square, 25 is a perfect square, and they are subtracted. Difference means subtraction. So we're subtracting perfect squares. So anytime you see a subtraction problem with two perfect squares, this is what we're doing. Okay. This is just going backwards on that shortcut that we had back in 7.3, not the one that we saw in the warm-up, but the other one. If you recall, that other one was if we had a plus ba minus b, it just ended up being a squared minus b squared. Well, now I have a squared minus b squared, so I'm going to break it up into a plus ba minus b. So really, we're just saying what times itself gives me that, and those are my two values. So here I would have x plus 5, x minus 5. We're going to be able to do this anytime we have that difference of squares here. Yeah.
What if they weren't squares and we had this?
If they weren't squares, then we wouldn't be able to do it. And then it would just stay as is. That would be as simplified as it would get. Yeah.
What if there's the addition sign?
Same thing. If there's addition in between, we can't do it. Yeah, we would just leave it. Cannot do it. So the only way that we can use this is if they're both perfect squares and their subtraction. If not, then we can't do it. And we'll talk more about that tomorrow. Tomorrow's kind of our bring everything together sort of thing. Today we're going to concentrate. They're going to work. Yeah.
But if it was a plus sign, wouldn't it just be x plus 5 and x plus 5?
No, because then you would have that middle term, right? If it was x plus 5, you'd have x squared plus 10x minus or minus 10x minus 25 or whatever. Right? You'd have a third term in there if you FOIL it. Okay. All right. So let's look at, let's say, 9x squared minus 100. Go ahead and factor that, please.
Let's just do the same thing we were doing yesterday.
We're doing this, right?
But there's a 9 in front.
Yeah, that's still a perfect square, 9 perfect square, right?
Yep.
So think about what times what is going to give you that 9x squared. Go ahead, talk to somebody about it. See what they have.
Yep.
I got
3x minus 5.
What?
You got
Okay, here we go. Here you go. Davey, what do you have?
Well, I just have a question.
Sure, what's your question?
What if never mind, it's really dumb.
Okay.
Not
Glad I
usually
could help.
it's a dumb.
Tim, what do you have?
Yes.
Yeah, there
I
is.
got 3x plus 10 and 3x minus 10.
There you go. 3x plus 10, 3x minus 10. Because 9x squared is just 3x times 3x, right? You're looking at what times itself is going to give you that. This is 10 times 10. So 3x plus 10, 3x minus 10.
What is the number before the variable?
then you can't do it. Yep, it's gotta be a perfect square. All right, let's do another one here. Let's go. Oh, let's go 225 minus 49x squared. Don't rearrange it, okay? Leave it as is. And factor it. Do the same thing you just did.
What times of week?
15. 15.
Hey, don't tell her. Figure it out. It must be really right there.
Oh, without you.
So what do we have this time around? Kenzie?
15 plus 7x and then 15 minus 7x.
There you go. 15 plus 7x, 15 minus 7x. Does not matter which one is the plus, which one is the minus, does not matter. Okay? You can have them in the other order, completely fine. Now, on something like this, okay, and you're gonna see something like this on the homework, do not switch these. I had some people last hour trying to switch these two values to make it 49x squared minus 225. You can't just randomly switch a subtraction problem, right? 6 minus 4 is not the same thing as 4 minus 6. So you can't just switch them, okay? Leave it as is, and we'll just leave this as our answer. Don't worry about standard form for that. Okay? Send it.
Can you just like put like negative 49x to the second like plus 5?
You could, but now we're not in that difference of squares format, right? You could, as long as you see that one is a minus, one is a, or one's a negative, one's a positive, you could still break it into this, right? But it's easier to see and recognize that if it's subtraction. All right, hey, you guys knocked off. Okay. Pay attention. All right, good. Let's do one more of these and then move on. I'm gonna throw you off a little bit.
Oh, no.
How about that? Oh.
Wait, you don't even know what I'm doing.
Oh.
This is just like normal,
Good thing.
I think.
He's 13 now.
Hey, before you get too far, what did we say in 7.6? What was the first thing that we have to do every single problem? GCF. Take out a GCF. Do it. Take out a GCF.
That's not.
If we don't take out the GCF, it is wrong. It will not accept it on big ideas.
We could have taken GCF out of those.
There was no GCF for the other. If you're taking the correct GCF out, it still should work. Oh, you gotta do this. If you're not taking the GCF out, the right GCF out, then it might not work for you. Go ahead, talk to somebody about it. See what they're doing.
Why do you? Oh, yeah. She got it. I forgot. I had.
Okay.
Look, 32.
What do we do now?
All right, guys, here we go. Here we go. Hey, so this is what I'm saying. If we don't take out the right GCF, you're gonna think that this problem is impossible. You're gonna be stuck. I heard some people saying that 8 isn't a perfect square. You shouldn't have an 8 anywhere in this problem if we take out the correct GCF. That's why GCF is so important here. Troy, what do you got?
16 parentheses x squared minus 4.
So we take that 16 out. 16 goes into 16 and 64. Okay, but we're not done. We're not done because in the parentheses is still a difference of squares. So we gotta keep going. Parker,
16 and then times x minus 2.
there you go. So after you take that GCF out, look in the parentheses, just like we did it in 7.6, right? Look in that parentheses. If there's still something we can do, we gotta do it. That GCF just stays out in front. Okay, yeah?
Can you do it if you don't pick up the GCF?
You can, but it's gonna become harder to have it completely factored out. Okay, we'll talk more about that tomorrow, about how we can catch it if we don't get the right GCF. Yep.
I discovered another solution that could possibly work.
Okay,
Take out 4.
so, and this along the lines of what Talon was saying, right? You take out a 4, you're looking at this, and then you're looking at 2x minus 4, 2x plus 4, but each one of these still has a GCF. So it's not factored all the way. And again, we'll talk tomorrow about how to completely factor something. But we gotta really take the best GCF, the biggest GCF out, which is the GCF, because that's greatest common factor. If you just take a 4 out, that's just a CF. Yeah. there you go. CF, not a GCF. Anyway,
Yeah.
any other questions right now on this one? Okay. Good, so now we gotta look at, oh, sorry, there's one more that you're gonna see on the homework, so I might as well point it out now. You're gonna see something like this. See something like this, okay? They don't want you to use calculator on it. We're not using calculator on it, okay? What we're gonna do, these are perfect squares. These are perfect squares. They're not on the list because 56 squared is just 56 times 56.
Oh,
Right? 54 squared is 54 times 54. So that means one of my parentheses is 56 plus 54. One is 56 minus 54. Right? It's the same idea that we just had over here. This is 15 times 15. Right? This is 7x times 7x. It's the same idea. It's just all numbers. Now, this is something that we should be able to do in our head. Let's, right? Yeah, 56 plus 54 is 110. Hopefully you can get there. 50 plus 50, 6 plus 4, right? What's 56 minus 54? 2.
2.
Nice. So 110 times 2.
220.
So there's our answer, right?
wow.
So that's the idea behind it. Okay, you will see a couple questions on the homework like this. Please try to set them up like this and not just type them into a calculator. Okay? Try to do the right thing. All right, moving on.
Why can't I just square them like no?
You could. How are you gonna? Do you know what 56 squared is without a calculator?
If I wrote it on the paper and did it, yes.
Sure, but isn't this faster than writing it on the paper?
Yes.
That's the point, right?
Yeah.
So, all right. So the other one that we gotta look at is going backward on what we did in the warm up. Okay, so that's gonna be something like 4x squared. Give me something like that. 4x squared plus 20x plus 25. No GCF between this. Not between all three. Right?
I've never seen that.
Oh, because you can't do.
Yeah, 2 doesn't go into 25. So yeah, the first thing we would do is look for GCF if we could, all right? There's no GCF here. But here's what we're gonna do, right? And this is the one where, yeah, it's gonna help us because it's gonna make it faster if we see it. If we don't recognize it, then we're stuck doing 7.6, where you're timing it by 4, you're factoring, you're dividing by 4, simple, right? That whole process. What we need to look at to see if the setup is there is we need to ask 2 questions. The first one, are the first and last terms perfect squares? That's the first question. Are the first and last terms perfect squares? Are they here?
Yes.
Yes. 4x squared is 2x times 2x. 25 is 5 times 5. So they are both perfect squares. And this is where, you know, knowing those perfect squares and having them pop off the page is gonna help you. Because when I look at this problem, I see right away that 4 and 25 are perfect squares. So I know, hey, this is a possibility. But the other thing that we have to check is we have to check the middle term. And I'll tell you what I mean by that. Remember that shortcut that we did in the warm-up in 7.3 was you had to multiply the two things together and double it. So we have to check to make sure that works. That means I'm multiplying these two things together to get 10x and doubling it to get 20x. So we're gonna say, is it 2 times A times B? Because that's what that general form was 2 times A times B. And in this case, it is, right? 2x times 5 is 10x, double it is 20x. That means this fits the shortcut. So then we take the 2x and the 5, and it's just 2x plus 5 squared. That's a whole lot quicker than going through that 5-step process from 7.6. So if we see it, if we recognize it, if it works, then use this. Okay, it's gonna be a lot quicker. Jackson? Then we can't do it. Then you're stuck with 7.6. Yep. Yeah.
If we did end up doing 7.6 on this, would we get it wrong because we wouldn't have the square?
You'd have the same thing. You would end up, if you did it the other way, you would end up with this,
Yeah,
which is the exact same thing.
but would we get Mark Johnson right that way?
No. No. I mean, it's cleaner to write it this way, but I wouldn't mark it up. Yeah. Okay, so that's our general idea here. Let's look at another one. Okay, talk it through with somebody. Check the first and last term, check that middle term, and then get an answer for it.
Oh, no.
So,
Yeah.
yes, 2x minus.
I know, right? It's insane.
All these I got the first one. First I like that. Vice versa. All right, guys, here we go. First of all, does this fit? Does this work with the pattern? Yes or no? Yes, it's done. Now, some people are confused with the negative in the middle. The negative is no problem. Okay? But this does fit. This is 2x times 2x. This is 3 times 3. Right? If I multiply these two together, I get 6x. I double it, I get 12x. What does that negative here tell me? What does that do for us? Gibby? Yeah, the only thing that it does is it changes that to a minus sign. Okay? That's the only thing that changes. So you can kind of ignore the signs. This last one has to be positive. Okay, it has to be a positive at the end because that's a perfect square. It's got to be a positive. Okay, but technically, right, this could be a -3 times a -3. And that's where we get that minus. Okay, yeah.
If we did it the 7.6 way, what would be the answer?
You still get the same thing. 2x minus 3 times 2x minus 3.
It's just a shorter cut.
This is just the shorter way of doing it. You're still going to get the same thing.
But the -3 times -3 is 9, not -12. Oh, no, 3 multiplied by 4, never mind.
Right? Yeah. Okay. So that's our idea there, okay? Very important that you are checking these two things. If it does not work, and we'll talk more about it tomorrow, but if it does not work with this, you cannot use the shortcut. So what you might see, right? Maybe this is, they try to do this a lot to you. They put a 10x in there to see if you're paying attention. And that's perfect square, that's perfect square. You multiply them together, you get 10x, but we didn't double it. So this one, we can't use the shortcut. So we gotta be aware of that. They're gonna try this at you to see if you can do it. At that point, you would say cannot factor or something like that. Okay? Or we would have to try 7.6. Don't try to do that. I don't think that's a good answer. I just made that up. Only other thing, and we've seen this all along, right? Is if they have it equal to 0, that just means keep it equal to 0, and then we need an answer at the end. Okay, zero product property, we've done that enough times to be able to get an answer out of it. Okay, just be aware you got that one little extra step at the end. 121, perfect square. There you go. All right, go ahead.